Welcome back to Science Modernizers. Welcome back to this video. Today we are going to see a question on moments of inertia. That's June 2015, question number 8. It reads, a thin uniform rod of mass 3m and length 2a is free to rotate in a free vertical plane about a smooth horizontal axis through a point P on the rod, where AP is equal to 3/4 of A. The rod is released from rest when PB makes an angle beta with the horizontal. So that the ensuing motion is 19/8 theta on the t, all of that squared equal to 24g into sine theta minus sine beta, where theta is the angle the rod makes with the horizontal at time t. When beta equals 0, b, find the magnitude of the reaction on the axis of rotation when theta is equal to pi on 3. So let's picture that. Now if PB makes an angle of beta with the horizontal initially when it is at rest, it means that the initial position of equilibrium was not completely horizontal. So here is our rod which is inclined at a given angle. Now initially the rod was inclined. Let us label our rod. So here we have A and on this side we have B. Now let's say this is the center of our rod. We can call it O. Now the distance from A to O is A, and from O to B is A, since the length of the rod is 2A. Now we have a certain point P, where P is placed at 3/4A. It is 3/4 A away from so the distance AP is 3/4 A, and so the distance from P to O will simply be A minus 3/4 A, which is A on 4. So that's what we have. Okay, so I'm going to remove this information. Let us picture some cases. Now we have here, these are point P. So at our point P, I'm going to call that my initial zero potential energy level. So that's my 0P level. So that's our axis of rotation. Now initially the rod made a certain angle alpha. So I will use broken lines to represent the initial position of my rod. So initially the angle which the rod made with the horizontal was beta, and so after a certain time t, when it was released from rest, the angle made by the rod is theta. Okay, so that's a little bit what we mean. Now notice the distance from P to A is 3/4 A, and the distance from O to P is A on 4. Now here what we have is we are going to resolve forces on our rod. So at this stage, here we have the width of the rod. Since the mass of the rod is 3m, so this will be 3mg. Now we have two components of the width. This other component. Now since this angle is theta, this angle will be theta. This angle will be 90 minus theta, and so this other angle here will be theta. And so if we resolve 3mg with respect to theta, what we have is we will have this component will be the cosine component. So here we will have 3mg times cos theta, and here we have 3mg. Let me use another color of ink. Here we have 3mg times sine theta. Similarly, the components of beta will be the same. That is 3mg sine beta and 3mg cos beta. Now we know that the distance, as we said, from P to O is A on 4, and the distance from A to P is 3/4 A. Okay, now in order for us to verify if that equation is true or to prove this equation, we are going to conserve energy on the system. Now what do we mean? From the law of conservation of mechanical energy, it states that the total mechanical energy of a system is constant. That is, energy initial for the system should be equal to the final mechanical energy. But mechanical energy is the sum of the kinetic energy and the potential energy. Initial should be equal to PE final plus KE final. Now initially, what do we have? The rod was at rest. So rod was at rest. So what does this imply? It simply means that the angular speed omega of our rod will be 0 rads per second, since the kinetic energy for bodies which are moving in a rotatory manner is given by a half I omega squared, or you might also see it as a half I theta dot square. Now for this system, we have that the initial potential energy PE initial will simply be equal to, now our rod initially was inclined at a given angle beta, and so the distance from the center of mass to our point of zero potential energy level is simply A14. And so it means, since we have the force, potential energy PE is equal to mg times h, but the width will simply be equal to mg, since our rod the mass was 3m, so that will be 3mg sine, that's vertical. So we are going to have 3mg, then times, we have the next, which is this height, this small height, so the equivalent vertical height. So what would that equivalent vertical height be? So I'm going to extrapolate this somewhere. So here we have A14. Picture it clearly, that's A14. Then we have a given angle beta. So we have a system like this. I have a line like this. Then here we have beta. So we can form an equivalent right angle. Now we see that this side will simply be A all over 4 sine beta. Okay, so it means the initial potential energy will be 3mg times A all over 4 sine beta. But you realize that this height is below our 0 PE level. So that's a 0 PE level. And since it is below, it means it should be negative in sign. So potential energy initial will simply be negative 3mg times sine beta. Now, the next thing that we are supposed to do, times sine beta A14, sorry, negative 3mg into A on 4 sine beta. So let's write it in a beautiful way. So this means PEI will be equal to negative 3 mga on 4 sine beta. So that's what we have as PE initially. Now let's now verify the final kinetic energy and the final potential energy. Now to get the kinetic energy final, the kinetic energy final is simply a half I omega squared. I'll use theta dot square. Now notice theta dot here is also known as d theta on dt. But we need to get the moment of inertia of our system. Now to calculate the moment of inertia of our system, we are going to use the parallel axis theorem. So I'm calculating the moment of inertia of my rod about the point P, and from the parallel axis theorem, the moment of inertia of our system about the point P will simply be equal to the moment of inertia from the center of mass plus md square, where this m, let me use capital M, times d squared. So m is the mass of the rod in our case, and d will be the distance from the centroid to the point P. So it means the moment of inertia of our system for a rod, which is the moment of inertia of a rod about an axis passing through the center, is given by ml square divided by 12. All these informations are given in the formula booklet, so you can verify them there. Now in our case, the mass of our rod is 3m. So I'm going to replace. So we have 3m times the length of our rod is 2a, all of that squared, divided by 12 plus md squared. So that will be 3m. Now the distance from our centroid to P is a on 4. So that will be a divided by 4, all of that squared. So this can go. So this means that we have, if you simplify, here we have m on 4, since this we cancel, then times, here we have 4a squared plus 3ma all over ma squared all over 16. So the 4's we cancel, so there I will have ma squared. So I will have ma square plus 3 ma square on 16. So if you take LCM, that will be 16 ma square plus 3 ma square, all of that divided by 16, which is 19 ma squared on 16. So that's the moment of inertia of our system. Now we proceed now by finding an expression for the final kinetic energy. So Ke final will simply be equal to a half times the moment of inertia of the system times theta dot square. So this means that kinetic energy final will be equal to a half. The moment of inertia of our system is 19 divided by 16 ma squared, all of this times theta dot square. And so if we rearrange, we have Ke final to be equal to 19 times 2 times 16 will be 32. So we are going to have 19 on 32 ma squared theta dot square. So that's the expression of the kinetic energy final. Now we go to the next. We now look for the potential energy final. Now our Pe final, it's when the rod has been displaced. Now when the rod has been released from rest, this is our rest position, it now makes a new angle theta. So it is simply going to be mgh. So Pe final will be mgh, so that will be 3m times the new height. So what then will be our new height? The new height will still be a all over 4, but this time around will be times the sine of the angle theta. So Pe final, our Pe final will be equal to 3mg into negative a on 4 sine theta. So what is it going to give? This will give us negative 3 mga on 4 sine theta. Now we are going to replace this in our energy conservation equation. Now we saw that Pe final initial plus Ke initial should be equal to Pe final plus Ke final. Now we are going to replace all our terms. Now Pe final, or let's start with the initial. Pe initial is negative 3 mga sine beta on 4. So we replace. So this will be negative 3 mga sine beta, all of this divided by 4. The initial kinetic energy of our rod was 0, so this will be equal to PE final is negative 3 mGa sine theta divided by 4 plus KE final, which is a half I theta dot square. Now this means we have to verify, or we have to prove the equation which was given to us above. Now if I rearrange, it means I will get a half the kinetic energy final already simplified gave us 19 on 32 ma squared theta dot square. So we have 19 divided by 32 ma squared theta dot square. This should be equal to, now I will bring this term this way, so this will be 3 mGa sine theta divided by 4, then minus 3 mGa sine beta divided by 4. Now if I multiply all through by 32 and I factor out 3 mGa on the right hand side, this means I will have 19 ma squared times theta dot square. This will be equal to, so I will factor out 3 mGa on 4. Now I'm multiplying all through by 32, so I will multiply by 32, and this will be, what will be left inside will be sine theta minus sine beta. So 2 will go here once, and 4 will go there once, and here 8 times. So therefore we see that we have 19 ma squared. So this implies we have 19 ma squared theta dot square to be equal to 3 mg. Now 8 times 3 will give 24 mGa into sine theta minus sine beta. So clearly we can already see that the proof is out. So a and one of these a's will cancel, m and m will cancel, but theta dot is the same as d theta on dt. Now this means that we have 19a, all of these times d theta on dt, all of that squared is equal to 24g into sine theta minus sine beta. So let's verify if they are the same. So we have this, which is actually it, so as required. So that's the first part of the question. Now what does the second part say? The second part says when beta equals 0, find the magnitude of the reaction on the axis of rotation when theta is equal to pi on 3. So I'm going to use another clean diagram so that we see that clearly. Okay. Okay, so for the second part, that's B, we have to find R, given that theta is equal to pi on 3. Now we are going to use here we had A, here we have B. Now at this stage we had our point P, and this was our 0P11, and here is the center O. You can say call it G if you want. Now the distance from here to here is A on 4. Now notice here I'm interested with forces, so I will not resolve all those distances. So at this stage we had the weight, we had W, which was 3 mg, and we had this component, the component was 3 mg sine theta, yes, after equilibrium was distorted, so it was 3 mg sine theta here we have 3 mg sine theta, and this way we have 3 mg cos theta. And so on the point of application here, we have our reaction force. So I will call this y, and I will call this x. So we are looking for the magnitude of the reaction force. Now you see that at the position of a given position of stable equilibrium, we are going to resolve the forces. Now to resolve the forces, we are going to resolve along the incline, that's along the rod, and we are going to resolve along the vertical incline, that means in this direction and in this direction. Now I'm going to consider the convention of my forces to be positive, so I will take it as such to be positive in that direction. So it means, if that is the case, it means my greater forces will be x and y definitely. And so I'm going to resolve my system. Now we have to note that for the vertical systems, or for the vertically, that's along the incline in this direction. So this is what we have. So I'm going to say that the sum of the forces along the vertical incline, that's in this direction, will simply be equal to mr times theta dot dot, and the sum of the forces along this direction will simply be equal to mr theta dot squared. So it's just like we have a transversal component and a radial component. So here we have a force which is acting vertical. So this is like a normal reaction force, and this is the x component of the reaction force, since the motion of the rod is rotatory. So we are not going to neglect any of those forces. So this is our angle theta, and they are given by these expressions. Now when we do the resultant for the first, so I'm going to consider, let's begin with the y, that along the vertical incline. So it means our system will be we have y minus 3 mg cos theta but this should be equal to who? mr dot dot. So our mass was 3m, the distance from O to P was A on 4. So the distance from A to P is A divided by 4 times theta dot dot. So theta dot dot is known as the angular acceleration. Now similarly, we have x minus, so we see we have x minus this component, and the component is 3 mg sine theta. But this should be equal to m, which is 3m. The distance to P is A all over 4 times theta dot square. But remember, from our proof, we can have theta dot square. Okay, now we don't have theta dot dot, so we are going to use our proof to deduce theta dot dot. So let's use another color of ink. Okay, let me use something more. Okay, now from our proof, what do we have? We had that 24G, or we had into sine theta minus sine beta was equal to 19a theta dot square. I'll use theta dot square. Okay, so we have to find theta dot dot, and to find theta dot dot, we simply have to differentiate that statement. So to differentiate the statement, we are going to differentiate implicitly with respect to theta. Now this means, what do we have? Beta is going to be a constant before theta. So it means if you differentiate, so as differentiating, so we are differentiating in order to find theta dot dot. So differentiating, we have this in expanded form, this 24g times sine theta. So if I differentiate, I'm going to have 24g times cos theta implicitly times theta dot, that will be times d theta on dt. Now the derivative of sine beta with respect to theta will be 0. Now this will be equal to 19a, yes, 19a times, we are differentiating theta dot squared, so it's going to give 2 theta dot dot times theta dot. Now at this level we know that beta was 0, so it will actually disappear. Okay, so beta is equal to 0, so sine beta is 0. So here we consider this to be a constant. Now the next thing we see is theta dot and theta dot we cancel, so this means we have 24g will be equal to 19 times 2, that will be 38a times theta dot dot. So this means my theta dot dot will be equal to 24 divided by 38a times g cos theta. So that's what we have. Now we can simplify. 2 can simplify. Here we have 12 and here we have 19. So it means theta dot dot will be equal to 12 all over 19a times the cosine of theta. Now with this we can find the magnitude of our forces. Now from our systems we had y, we can make it the subject, so y will be equal to 3ma on 4 times theta dot dot, so that will be 3ma divided by 4 times theta dot dot, which we just calculated to be 12 on 19a times cos theta. Then I will bring this term this way, transfer it this way. So what do we have? That will be plus 3mg cos theta, 3mg cos theta. Okay, I forgot I omitted a g here. Okay, so here there is a g. Now here this means a's we cancel out, we cancel out with a, 4 goes here, 1 here, 3. Now 3 times 3 will give 9, so here I will have 9 mg cos theta divided by 19 plus 3 mg cos theta. Now 3 mg cos theta is common, so I'll factor out 3 mg cos theta. All of this will be factored out of, what will be left here is 3 on 19 plus 1, so that will be 22 on 19. Now 22 times 3 is 66 mg cos theta divided by 19. Okay, so that's what we have. Now let's go to x. So for x will be equal to, we do the same thing, that will be 3ma on 4 theta dot square on 4 theta dot square plus 3mg sine theta plus 3mg sine theta. But we know from proof, that we had 19a theta dot square was equal to 24g into sine theta minus sine beta. Now from here we can calculate theta dot square. So since beta equals 0, this implies that sine beta will be equal to 0. So it gives us theta dot square to be equal to 24g sine theta divided by 19a. So I will replace in x. So this will give me x will be equal to, we have 3ma on 4 theta dot square. So that will be 3ma divided by 4. Our theta dot square is 24g sine theta divided by 19a, then plus 3mg sine theta. Okay, so here we have, let's simplify. 4 goes here 6 times. 6 times a's we cancel out. So this means x will be equal to 3 times 6, that's 18m. So we have 18mg divided by 19 sine theta plus 3mg sine theta. So that's what we have. Okay, now this means x will be equal to, I can factor out 3mg sine theta. What will be left? 6 on 19 plus 1. So this means x will be equal to 3mg sine theta into, this will be 25 on 19. Now 25 times 3 is 75. So this means x will be equal to 75 mg sine theta, all of this on 19. So here we have gotten our reaction forces. So x is equal to 75 mg sine theta on 19, and y is equal to 66 mg cos theta on 19. 66 mg cos theta divided by 19. Now, but we want to calculate it when theta is equal to pi on 3. So this means we have our x will be equal to 75 mg sine pi on 3 on 19, and y will be equal to 66 mg cos pi on 3 on 19. Now sine pi on 3 is 60. Sine 60 is root 3 on 2. So sine pi on 3 is equal to root 3 on 2, and cos pi on 3 is a half. So this means our system we will have x will be equal to 75 root 3 on 38, or 75 mg, 75 root 3 mg divided by 38, and the other one will be half times 66 will be equal to 33 mg on 19. So that's what we have as x and r, and so we are asked to find the magnitude of the reaction force. So the reaction force r will be the square root of x squared plus y squared. So this means my r will be equal to the square root of 75 root 3 on 38 square all of this squared plus 33 on 19 all of this squared. So what I've done is I've removed the mg, since all of this will be times mg squared will be factored out, so times mg. So now this means our r will be equal to square root of, so we have to punch. So we have 75 root 3 square so this above gives 16,875 divided by 38 square, which is 1444 plus 33 square, which is 1089 divided by 19 square, which is 361. Okay, now this means if we sum times mg, if we sum we have 16,800 so it's going to give 14.7 mg. That's what we get as final result. Or if you want it as a whole fraction or as a fraction, r gives 14 whole number 1015 on 1. Oh, I didn't take all of this is in the square root, so this on 1444 mg, but this is in the square root, so I didn't take the square root. Okay, now in other words, in a good fraction it will be 14 times 1444 plus, so if you convert this to an improper fraction, it will be the square root of 21231 divided by 1444 times mg. Okay. Now if you take square root of 21231 divided by the square root of 144, so this R is approximately, but it will be exactly equal to 3 divided by 38 root 2359 mg, which is approximately 3.83 mg. So that's the magnitude of the resultant force. So this actually brings us to the end of this video. Thank you for watching, and please do not forget to like, share and subscribe. Simo 413 is our YouTube channel name. See you in the next video.